Once we have collected our data, whether that be through a survey or going out and counting things, we need to be able to put it into a format that's easy to read. So often we use a frequency table, or sometimes it's called a frequency distribution. So looking at this example here, you can see that people were surveyed on their favourite ice cream flavour, and the options were vanilla, chocolate, mint choc chip, strawberry, cookies and cream. The tally column helps us just to keep count of the number of people. So it's no more than just a tool for counting. The frequency then is the total number of the tally. So you can see 2 strokes there means that we have got a frequency of 2. If we were to total our frequency column, so 2 plus 5 is 7, plus 4 is 11, plus 3 is 14, plus 6 is 20. Really, that means that there were 20 people who were surveyed. So we can really check to make sure that we have included all of the data that was originally surveyed. Now, once you've got your table, that is one way of looking at your data, but another way then is to use that table and put it into a column graph. So a column graph has got the frequency on the vertical axis and then all the categories on the horizontal axis. So ice cream flavour is on the horizontal axis here. We should always label our axes, so frequency and ice cream flavour, and we should always give our graph a heading. So favourite ice cream flavour is our heading here. Down the bottom are all of the different categories. So a column graph is used for categorical data, or if we were dealing with numerical data, it would be numerical discrete data. So what is a column graph? Well, you can see the columns go up to the frequency. So vanilla was 2. Our bar is going up to 2. Okay. For chocolate, the frequency was 5. So our bar goes up to 5 and so on. Now our frequency has a scale. We are going up in ones from 0 through to 6. So that's really important that we have a proper scale there. And have a look at the columns. They are all the same width. Okay, all of those columns are the same width, and the space between the columns we try to keep the same as well. So there is some symmetry there to that particular graph. In this example, 20 people checking out of a hotel were surveyed on the level of service provided by the hotel staff. So the options were poor, average, good, first class. Well, what we need to do here is create a frequency table in order to tally up those responses and then work out what their frequencies are. So the table is set up and the 3 columns are response, tally and frequency. And of course, under response now, we put all of the categories that were responses. And of course, our 4 responses are poor, average, good, and first class. Now, the easiest way to do this is to use your original data and put a line through it so that you can keep count of whether or not you've actually counted it. So we're going to start with poor. So 1, 2, 3. So my tally is 1, 2, 3, and my frequency is 3. And then I'm going to do exactly the same for all of the other ones. Average is 4, and so has a frequency of 4. Good has got 8. Now look at the way I do this. 1, 2, 3, 4. The stroke across means 5, 6, 7, 8. So my frequency is 8. Remember, my frequency is a number. And counting first class, we get 5, 4, 5. Now we knew that there were 20 people. 20 people. Does my frequency total to 20? Let's have a look. 3 and 4 is 7. and 8 is 15, and 5 is 20. So I can see there that I have counted every single response. Constructing the column graph now, I need to give it a heading first of all. So I might call mine level of service provided by hotel staff, just trying to summarise what it's all about. The next thing to do is to label your axes. So we always have frequency on the vertical axis, and on our horizontal axes we've got our responses. And I need a scale now for my frequency. Well, my biggest frequency is 8. You can see that from our table. So I need to go up to 8. I have to decide on a scale. Because 8's a small number, I could easily go up in ones. And on my horizontal axis, for the responses, okay, I need to put poor, average, good, and first class. So poor, I might actually just use the letter here. So P for poor, A for average, G for good, and F for first class. So I've got P, I've got A, I've got G, and I've got F. And I'd probably have to put some sort of key there to let people know what those letters stand for. My next step now is to draw in the columns. So poor had 3 responses. So I draw my column around the P and I go up to a frequency of 3. Average had 4. Now I do that one up to 4, and I'm trying to keep the columns the same width as best as I can. The next one is good. And the last one is first class, which goes to 5. So what you can see there, we're trying to keep our columns the same. Don't have to be exactly, but just around about the same width. And also the spaces in between those columns, we're trying to keep the same. So we're looking for some sort of symmetry there. So if I looked at that graph without looking at all of the original information, the table or the raw data, I should be able to know exactly what I have graphed there. And so I look at it and I go, the level of service by hotel staff, okay, and of course poor, average, good, first class, and I know how many people have responded. I know because it's frequency and response on my axes, so it stands alone. In this example, we're looking at numerical data. Numerical data can be discrete or it can be continuous. We already know that. And the way that we actually display numerical data is to use a histogram. What's the difference between a histogram and a column graph? Well, we can see over here that there are no gaps in between the bars, but we still have the frequency on the vertical axis, and we would still label our horizontal axes. Sometimes we're asked to put percentage frequency in, but this isn't always necessary for a histogram unless you're actually asked for it. Now, discrete data is not that different to what we've just done in the last graph. But continuous data, what we might need to do is create class intervals. So what is a class interval? Well, sometimes we have so much data, and in this case, the data is going from 10 right through to 40. This would mean that our table would be extremely big if we had to go from 0 up in ones through to 40. So we group it in blocks. We can decide what the blocks are as long as those blocks are all the same size. So in this case, our blocks or intervals are 10s. So the first one goes from 0 up to, but not including 10, because the next one starts at 10, and then the third one starts at 20. So that's all of the values from 20 up to, but not including 30, because the next interval starts at 30. Now, if you have a look at each of those intervals, they are all the same size, and that's what we need to have. So what do we have in this case? Our frequency is 3 for a class interval between 0 and 10, which means we have 3 values between 0 and 10. The next one, 5, means that we have 5 values between 10 and 20, but not including 20. The next one, we have 8 values between 20 going up to, but not including 30. And then the last one, we have 4 values between 30 and going up to, and in this case, we would be including 40. Okay, percentage frequency. We'll have a look at that in a minute. Let's have a look at an example first. 20 people were surveyed to find out how many times they use the internet in a week. The raw data are listed. Okay, raw data, which means we now need to do something to display it. So the first thing that we're asked to do is to organise the data into a frequency table. And we're asked to use class intervals of 10, which is what we saw in the previous example. And we also need to include a percentage frequency column. Well, let's start with just doing the frequency table part first, and then we'll add the frequency column on. We know our smallest number here is 2 and our biggest number is 4, just looking at our data. So what we're going to do now, after we've set up our table, you can see the 4 columns there are internet usage, tally, frequency and percentage frequency. And because we're using class intervals of 10, I've gone 0 and the beginning of the next interval, which starts at 10, 10 up to the beginning of the next one, which is 20, and 20 all the way up to 30, 30 goes all the way up to 40. Okay, so where do we go from here? Let's start with all the numbers between 0 and 10, but not including 10. So you can see 5 and 2. So that's a tally of 2 numbers and a frequency of 2. Next one are all the numbers between 10 and 20, but not including 20. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, frequency of 8. And we do the same for the next 2 intervals. Okay, having finished all those now, remember we had 20 people. So what should our frequency column add up to? Should add up to 20. 8 and 2 is 10, and 5 plus another 5 is 20. So I have used all of my data there. Percentage frequency. To calculate the percentage frequency, we take the frequency, which in this case for the first one is 2. We divide it by the total number, which is 20, and we times it by 100. So when you do that, you get 10%. The next one is 8 out of 20 times by 100. That is, put it into your calculator, you get 40%. And the next one, 5 out of 20 times it by 100, and you get 25%. And of course the next one must be exactly the same, because it's so 5 out of 20 times by 100 is 25%, and our total for percentages should add up to 100%, which it does. So there is our frequency table with a percentage frequency column added on, and we are using class intervals here because we have so much data. Now, just looking down the bottom of the page there, sometimes we're asked to describe our histograms. And so in describing them, there's probably 3 terms that we need to become familiar with. So symmetrical, positively skewed, and negatively skewed. The way that I like to remember it is symmetrical is when something is pretty similar on both sides of the middle. So it doesn't have to be exactly the same. I would actually call this approximately symmetrical rather than symmetrical. So that side, if I put a mirror down the middle there, it looks the same or approximately the same on both sides. Now with positively skewed, what we're looking for here is the tail bit moving in the positive direction. So you can see that it's getting smaller as we go in the positive direction, and therefore negatively skewed, the tail is moving towards the negative direction. So they are the three terms that we need to be familiar with in describing our histograms. Using the table that we've just put together on the previous page, we are now going to draw the histogram. In this case, they want both the frequency and the percentage frequency. So on the left-hand side, I'm going to put the frequency. Now my highest frequency was 8, so I did have to go up to 8. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and percentage frequency on the right-hand side. So each one is 10%, so that is 10, 20, 30, 40, 50, 60, 70, and I don't need to go any higher than that because my highest percentage was 40 anyway. I do need to give my graph a heading. Let's get into the habit of doing that, and I'll do that in a different colour so that we can see it. It is the internet usage that we are graphing here. Okay, and let's start. Don't forget to label this bottom axis here. So this is the number of people. Now the number of people went from 0 to 10, 10 to 20, 20 to 30 and so on. So we're going to start from 0, and then beginning of our next interval is 10, and the beginning of our next interval is 20, beginning of our next interval is 30, and the beginning of our next interval is 40, if you like. So we now have to fill that in. So for the first one, between 0 and 10, but not including 10, was 2. So we have to go up to 2. Between 10 and 20, but not including 20, there were 8. So we had to go all the way up to 8. Now, if you've done your frequency, percentage frequency to scale on the right-hand side, you shouldn't have to worry about that too much because it should line up with your frequencies. Next one has to go to 5. And of course our last one goes to 5 as well. So that's our histogram for internet usage for 20 people. Part C asks us what interval is the most frequent. So we're looking for the highest one there. This one has the highest frequency of 8. So the interval, which was 10 right up to 20. So it is the one that does not include 20 but starts at 10. And then part D said what percentage of people use the internet 20 times or more? So 20 times or more, what are we looking at from our graph here? 20 times or more would be from here upwards. And we can see there that we have 5, 10. So there are 10 people, but what is that as a percentage? Well, we know it's 10 out of 20 times by 100, which would be 50%. So what percentage of people use the internet 20 times or more? It was 50%, or half of the people. So what you've seen here is a histogram. All of the bars are the same, no gaps between them. Frequency on the vertical axis, heading, labelling all the axes, looking for good scaling. There's lots of little particular things that you have to be careful with. And again, it needs to be something that someone can look at and read off the information straight away without looking at the raw data to know what it's all on about.